more. Today I'm going to be making the part 2 of the time series analysis on my mood. Actually, this is not just a time series analysis, it's also going to be combined with multivariant analysis, that is considering the correlation between different factors that have been considering throughout the collection of my mood data and other health data as may be required. So what you're seeing on the screen, for those who are familiar with it, is Power BI. So from the last time that I've been analyzing my mood using time series analysis, I noticed something. Now what I noticed is this. I noticed that the 12-day seasonality and the 7-day seasonality seem to be quite interesting in predicting the fluctuation of my mood. So I made a forecast from July 10 to July 18 using the 7-day seasonality settings, and this was what I got as the forecast. Now when I used July 12, this was what I got as the forecast. Now you notice the shape, they have quite similar shape. The 7 and the 12 have similar shape from the start and the end, although something else was happening at the middle of it. Now the actual one, what really happened was this. You can see that it looks very similar to the 7, meaning that the 7 is a good predictor of my mood. 7-day seasonality is a good predictor of my mood fluctuation compared to a 12-day seasonality. 12-day seasonality just kind of seem to be predicting it at the start and at the end of it, but 7 days seems to be a bit more uniform and more accurate at predicting my mood. Obviously it's not going to be purely based on a time fluctuation or a seasonality fluctuation. My mood is not purely based on time and mood. There are other factors that are involved, which is why I'm including a multivariate analysis on my mood fluctuation. So we are going to be employing JMP to understand exactly what might be happening responsible for the fluctuations in my mood. Everyone has a mood fluctuation. It's not like this is an abnormal thing. People have good days sometimes, people have bad days sometimes. We are just trying to demonstrate how data analysis can be used for understanding what is going on in personal life, and we can use this to have a more predictable and better lifestyle and a better experience through life. Now looking at this, we are comparing. This is a matrix. Yes, this is a matrix. Now this matrix is calculating correlation between all the different factors among themselves. The more blue the color of this number you are seeing here, the more positive the correlation, and the more red the color, the more negative the correlation. Positive correlation means the higher something is, the higher the other one. Negative correlation means the higher something is, the lower the other one, and vice versa. Positive too also means the lower something is, the lower the other too, and vice versa. Now looking at this, obviously mood will be correlated with mood, negative events will be correlated with negative event because they are the same thing. That's why it's 1 and it's positive and it's blue in color. Now the negative ones are these ones that you are seeing here that are red and they're having negative mark. Now let's look at what is going on in this minus 0.7383 correlation. It means that stress is negatively correlated with sleep quality, and when you think about it, you will see that it's true. The more stressed I am, the less my sleep quality, and the higher the sleep quality, the lower my stress level. So there's a negative correlation between stress and sleep quality, which actually makes sense. Now a higher sleep quality means that yes, I slept well, I slept at the right time, I had a normal proportion of deep sleep, light sleep, and rapid eye movement sleep stages. Those are the factors that I use to calculate the sleep quality. All these data were collected from my smartwatch. There's also a negative correlation between stress and sleep duration. So the more I sleep, the lower my stress is going to be that day. That's what it means. And also I can also see some negative correlation here too. Some sort of negative correlation in standing. So this standing just shows the hours that I stood for while moving, actively moving, taking at least 20 steps while standing. It shows the quantity in hours. So you can see the more I stand, the more my sleep for that day. So me taking so much standing for a very long time would mean that I will probably sleep for long or probably have a better sleep. Not very negatively correlated, but some degree of negative correlations are happening there. Now there's another interesting thing I want you to see, this positive correlation here. The higher the sleep duration, the higher the sleep quality, which actually makes sense. Yes, that actually makes sense. And the lower the sleep quality, the higher the stress level, which actually makes sense. Lower the sleep duration, the higher the stress level. So those are the relationship that we can actually find there. And let's look at the negative event and positive event, which makes sense. Negative event is negatively correlated with mood, meaning that the more negative events I have, the more likely I'm going to have a what? A low mood. And look at positive events is correlated with my mood. That means that the more positive events I have, the better my mood, which actually makes sense. There are some other correlations here to, like temperature and AQI. Look at temperature and AQI. Higher temperature means what? Higher AQI. That's the air quality index, which is actually true. When there are more particulate matters in the air, this is going to increase the AQI. And when there are more particulate matter in the air, it will tend to increase the temperature. This data was collected from an openly available data source online. Now let's see if there's any other correlation there that might be interesting. So those are the major correlations: sleep duration and BPM. Okay, there's a correlation between sleep duration and BPM, a negative correlation, sort of. So you can see that the higher the sleep duration, the lower my BPM, or the higher my BPM, the lower my sleep duration. So if I'm much more stressed out, indicated by high blood pump, high beats per minute, the lower sleep duration I'm going to have that day. There's a correlation. There's a strong correlation between stress and sleep duration also, meaning that when I have a low sleep duration, my stress level is going to go up. And when I have a low sleep quality, what happens to my stress level? It goes up, which actually makes sense. So these are the factors that are having the most significant influence on my daily mood. And how is this relevant? It's relevant because now that I know the factors that are influencing my mood, I can then begin to make some lifestyle changes that is going to improve my day-to-day mood. I know that when I sleep for long, when I have a better sleep, my stress level is going to reduce. At the same time, my mood is also going to improve, sort of improving. With a higher sleep quality is correlated to what? A higher mood also, sort of. And this is also strongly correlated. Positive events and sleep quality. On days that positive things happens to me, I tend to sleep better that day, which actually makes sense. So overall, all of this data is based on 66 data points, which is not statistically significant. I need to collect at least a year of data, 365, for it to have a good p-value of 0.05, which is going to be statistically significant. So this is just like somebody has been studying me for the past 66 days and is trying to predict how my mood is going to fluctuate. Is trying to, using time series analysis, trying to predict the factors that are influencing my mood and how they are correlated with each other. So this is just multiple analysis that is being done on different things, which include time series analysis and multivariate correlation analysis. I hope you enjoyed this, and also I would like to also show you this Power BI, which I've already shown here. Exactly. So now what this Power BI is trying to say, now using time series analysis, Power BI is trying to tell me that I'll have the best day on August 7 and I'll have the worst day on August 11 if there's a 7-day seasonality for real. Now if there is a 12-day seasonality, it's trying to tell me that I have the best day on August 10 and then the worst day on August 9. That is, a day before 9 is going to be really bad, and then the next day suddenly I'll have a good day. If truly there's a 12-day seasonality. So let's see what's going to happen for the next 7 days and see what seasonality, either 7 or 12, is going to be, give us an accurate day. Now I want you to realize that before I could conclude on the 7 or 12 days, I tried several days. I tried to forecast based on 11 days. I forecasted based on 10 days. I forecasted based on 9 days. I forecasted based on 8 days and 6 days, for me to finally see that the 7 days, there's a 7-day seasonality and a some sort of 12-day seasonality in my mood fluctuation. I hope you enjoyed today's presentation. I'll see you again in the next video.